Hi, today we are going to discuss about the concept of banking of roads. So, banking of roads concept I am taking for friction case. Okay, this is given for safe negotiation of the driving. So, if you take an inclined plane, suppose there is a vehicle. So it is like this. When you see from the top, the vehicle actually is going like this. Okay, however, this is not flat but inclined. Okay, now let us say we have to draw the free body diagram here. Its weight is acting downwards. The normal reaction will be always perpendicular to the plane. So this is N, and so you can see here the center is somewhere here, as discussed in this point. So this will have two components. If this is theta, if you work it out, you will find this angle also as theta only. So this is n sine theta, and this is n cos theta component. Basically, in these type of problems, you have to first First, you have to resolve the vectors, and here two possibilities are there. Suppose if I am taking the possibility n sine theta is greater than mv square by r. Let us say this, when I am saying this as center, this will have certain radius, no? So if I take this possibility, the vehicle will have a tendency to move down the plane. So in that situation, the friction will be acting upwards. The friction will be acting upwards. So again, because if this is theta, so you have this also has theta. So friction also will have two components, F cos theta and F sin theta. Whenever we are solving any problem, we have to take x and y. So here the easier convention would be you take x along this direction and y along this direction. So solving the problem becomes easy. If I take x along this direction and y along like this, will I get any different answer? I'll get the same answer only. Only it will make the problem little tedious. We always try to simplify our problems. Okay, so if you take in x direction, you have to see what all forces are acting. So in x direction, you have we have not resolved this mg also will have components mg cos theta and mg sin theta. Okay, so after writing all the forces, we need to just write the forces in x and y direction. So in x direction, we have mg sin theta. If I call this as positive, so this is in the negative direction, then plus we have, okay, now because I am taking this direction as my final calculation purpose, so I will write, so let us not take this direction because we have resolved these vectors like this, no? So I will consider this as the direction here. This will be more easier in this case rather than this case actually. Okay, this will be more easier. So small correction. So in x direction, so this is not required. X direction, you have f cos theta, then you have minus n sin theta. That's it. You don't have any other force. mg is acting vertically downwards. You don't have to consider these components. So there is no other force. So it's equal to 0. You know that F is equal to mu times the normal reaction. This is equation 1. This is equation 2. Then we will write in the y direction. In y direction, So we have f sine theta, that is in the upward direction. Then you have minus mg, and then you have n cos theta, which is also in the upward direction. So plus n cos theta is equal to 0. So here we have framed three equations, and after that it is solving of these three equations for our finding unknowns as given in the question. Okay, usually the unknowns are, usually mu will be given. So the unknowns here are this n and theta.